Transmit.
Eugene I is really excited for Halloween. As he hops around the neighborhood, Eugene sees a bright orange pumpkin. He wonders how he sees it. Eugene learned in AP Psych that the color he sees comes from light waves. These waves are on the longer end of the visible light spectrum, which is a part of the bigger electromagnetic spectrum. In addition, the waves are also taller since the pumpkin is so bright. A witch comes up to him and tells him that he can see the pumpkin because transduction is allowing him to receive light energy and transform it into neural messages that the brain can process. Eugene still does not understand. But how does it process through the eye? Eugene asks the witch.
This is the fun part, the witch cackles. First, light passes through the cornea, a transparent dome of clear tissue that bends light to focus and eventually create the image you see. The light passes through a hole in the iris called the pupil. The light then filters through the lens and focuses into the retina. Once in the retina, the light filters through several layers of tissue. The light rays go through the ganglion cells, and then the bipolar cells, and from there connect to either a rod, if black, white, or gray light, or a cone, which according to the trichromatic theory and opponent processing theory, the trichromatic colors, red, green, and blue, end up working in teams with their opponent color. This is the part where you begin processing color. After it, the axons of the ganglion cells, which is the optic nerve, send the info to the brain.
Now let's back up a little. Before the light hits the bipolar cells, light energy triggers chemical changes that spark nerve signals in the retina. This then activates the bipolar cells. When you are focusing on an object, you are using your fovea, which brings the pumpkin into clearer vision. Eugene, since you wear glasses, can you see Can you see far? No, Eugene replied. Okay, the witch responded. This means you are nearsighted, aka you have myopia.
When light rays focus onto the retina, the image appears upside down, which happens to everyone. But when you are nearsighted, your eyeball is too long, relative to the focusing power of the cornea and lens. Therefore, the light rays focus at a point in front of the retina. Once the image reaches your brain, the image has been flipped right side up. But for you, it appears blurry because the pumpkin is far away. Wow, Eugene says, that's a pretty scary process. But when Eugene looks back at the witch, she was gone. Happy Halloween, Eugene mumbled under his breath.